Hello guys and welcome back. We're looking at chapter 3.4. We're looking at the chain rule. Here we have the definition. We will work out the problem 18 and 34 in this problem. I hope you guys are liking this channel. Please subscribe, like, and share. This is Calculus 1, chapter 3.4. So here's our first example. We have f of x equals to the square root of x squared minus 2x plus 1. Let's try to identify first our f and our g based on our chain rule definition. So if I look at it from that point of view, my f of g of x, I need to identify these two. So in my example, if I rewrite this here, I have x squared minus 2x plus 1 raised to the 1/2 power. So now based on that definition, I can identify that my g of x in my definition here, g of x is equal to x squared minus 2x plus 1. Now, on the other hand, my f of x is equal to simply g of x raised to the 1/2 power. So in other words, my g of x, it's here, and all of it is raised to the 1/2 power, as you can see there. Now, in order for us to complete this problem, let's try to take the derivative based on that definition. So the derivative, let's use a different color. The derivative with respect to x. In this case, I'm going to call it g. It doesn't matter the name right here, but it's f of g of x. And that is equal to, in our definition, we have the derivative of f prime, which is simply multiplying leading coefficient times the power. So that will be, let me increase this a little bit so that way it makes sense. So that will be 1/2. We keep g just as it is, which is x squared minus 2x plus 1 within parentheses, and then we have 1/2 power, and we need to subtract 1, which is 2 over 2. Then we need to multiply by g prime. So we need to take the derivative of g, so times, and g is here, as you can see. So that will be 2x minus 2. And that's it. Now we need to simplify a little bit more. This is equal to 1/2. And here we have a negative power. When we subtract that, it's 1/2. So basically I can bring this down, since it's a negative, and just keep it as it is. And up here I have 2x minus 2 times 1 there. Or I can simplify this furthermore by factoring out a 2. So I get an x minus 1 all over 2, the square root of x, x squared minus 2x plus 1. And now we can cross out the 2's there, and that is our final solution, which is x minus 1 within parentheses, and then the square root of x minus 2x plus 1. Okay, now let's take a look at the second problem here. We have g of x equals to 3x squared minus 1 over 2x plus 5, all of it raised to the 3rd power. Now let's try to identify f and g. So in our example, in this example, we have g of x, which is simply everything within the parentheses here. And if I call that my g, therefore my f of x, it will be equal to g of x, basically raised to the 3rd power. That's the interpretation. Now let's do that. So the derivative with respect to x of f of g of x. This is equal to, now we need to take the derivative of f. So the derivative of f, in our case, it will be simply our power times our leading coefficient. So that will be equal to 3. And then we need to keep g just the way it is. G is 3x squared minus 1 over 2x plus 5. And that will be raised to the third power. And then we need to take away 1 from it. And that will be my f prime. So now I'm taking the derivative of my, the expansion of g there based on the definition here. As you can see, g prime there. So the definition for that will be simply taking the derivative of g. In our case is 3x squared minus 1 over 2x plus 5. And as you can see, we have the quotient rule down here. So where f, it's the function at the top, and my g is the function at the bottom. The definition says equals to g times f prime minus f prime times g prime. So let's do the notation then. So we have our f of x for our quotient rule will be simply 3x squared minus 1, and our g of x equals to simply 2x plus 5. Now we're looking at the piece of the quotient rule. Keep that in mind, okay? So I could label it G1, G2. It doesn't matter as far as the definition, just to identify them. But now let's take the quotient rule. The quotient rule will be G, simply keeping G just the way it is. So I'm going to use, let's use a different color to differentiate that. And we have simply G, which is 2x plus 5. And that is multiplying times f prime. So the derivative of f prime here, it's simply 6x. So times 6x minus, we have a minus sign here, as you can see down here, f of x. We need to keep f of x now. F of x is simply 3x squared minus 1. Then we need to multiply times g prime. So now the derivative of g prime is simply equal to 2. So times 2 there. And that's all over, that will be g squared, which is the denominator square. So 2x plus 5, all of it square. Now I'm ready to simplify furthermore. I have basically 3 there, and then I have 3x squared minus 1 over 2x plus 5, and then as we simplified this power here, we get simply a 2 times, and then we need some square brackets to differentiate. I'm going to rewrite this 6x, I'm going to have it up front. So I have 6x, and then we have times, parentheses, 2x plus 5. And then we have a minus sign in here, and I need to rewrite the 2. This 2 here, I'm going to put out front as well, 2. And then I have 3x squared minus 1, and that's all over 2x plus 5. And that will be square. Okay, now we need to identify to see if there's anything related that we could simply eliminate, but it looks like our numerators on the second piece of it doesn't have any like terms, but we can still simplify furthermore. So we have equal to, we have a 3 there. As you can see, I can split this apart into 2 pieces, to 2x squared minus 1 raised to the second power over 2x plus 5 raised to the second power times, and then my square brackets, I can utilize that for the top portion of it. So I can have square brackets 6x times 2x plus 5 minus 2, 3x squared minus 1. All of it raised to the 2x plus 5 squared. And now when I simplify this, I simply get equal to 3, 3x squared minus 1 square times, and I have 6x times 2x plus 5 minus 2, 3x squared minus 1. And I can have, let's have square brackets here to identify right here. And that will be all over the 2x plus 5 raised to the 4th power, since these two numbers add up. Alright, so that is the final solution for this problem. I don't have anything to simplify furthermore. Once again, if you're liking this channel, please subscribe and stay tuned. Like and share. Thank you so much for watching. Goodbye now.